Okay, so we're talking about relative dating, and that means we're talking about the age of rocks based on where they are relative to other rocks, right? Like we say, it's all relative. Well, it depends on how you look at it, right? So for the first, and we have these basic rules or laws for relative dating, and so you have the law of superposition, all right, and that just means that the older rocks are at the bottom. Okay, so you have these sedimentary rocks, and they get deposited in these parallel layers. All right, just naturally, gravity is going to make them all at the same, lie down parallel, get deposited parallel. And so the oldest ones are at the bottom, and the younger ones are at the top. That makes sense. These were here first. This got deposited on top of that. The basalt got deposited on top of that, and then mudstone on top of that. Okay. Strata just means this, where you have layers, right? Strata, like a layered, you eat like that's kind of a dish, right? That has layers. And again, the oldest layer is at the bottom. Okay. So that is the law of superposition. Oops. The cross-cutting law, it comes from that law of superposition. So we have our layers, right? Here's my oldest layer. And this layer got deposited on top of that, then this layer, this layer, this layer. So all these layers were here. The magma here came in and squeezed into the rock that was there. All right. So, anytime you're going to have a break or a fracture, you have a crack in the rock, and so the magma can get in there. And this magma that has come, this rock here, all right, that cross cuts, those are all going to be younger. Right, those would be the youngest rocks. They're younger than the rocks that they cut across. Okay, this would be the oldest, second oldest, third oldest, fourth oldest, fifth oldest, sixth oldest. These all had to be here. All right, this all had to be here first in order for this rock to form inside it. Okay, so the youngest rock would be these ones that are cross-cutting. Okay, so if it cuts across, all right, it is younger than the rock that it cuts across. All right, and that is the cross-cutting law. And here's a good word, batholith, right? That just means you have a solid rock inside inside the earth. Okay, and what happens is it can with the uplift it can reach the surface. All right, but batholith just means you got a big solid chunk of rock. And there it is. So the law of inclusions. All right, so law of inclusions says if I have a rock body. All right, so here is, I've got this solid rock, all right, I've got A and B. So A is the oldest, right, because it was laid down there first. Then you have B would have to be next, right, that's the oldest. Then came B, all right. And see these chunks of B are inside of C. The next thing that came in was C is my intrusion. All right, so this is my intrusion. Right, it's squeezing into these rocks. All right, so that would be the youngest, right? And this rock here though, this was part of this guy. All right, these are my inclusions. Inclusion. And so they are actually older than this rock C. Okay, because the inclusions, this is rock 2. That's that second level that got mixed in there. Okay. So the inclusions are older than the rock it contains. Right. So here we have, here's some pictures of inclusions. Are these rocks here? Okay. So the oldest rock is here on the bottom, right? Law of superposition. And then, so that's the oldest, the second oldest, the third oldest, right? And then I have the fourth oldest. Here's this layer, all right? This rock and the inclusions are part of this rock here, all right? And so they're the fourth, these inclusions are the fourth oldest. Whereas this layer of rock here, right, this layer, this layer is the fifth oldest. Okay, so the inclusions are older than the rock that it's in. All right, so it's kind of that it's opposite of cross-cutting. All right, if we go back to cross-cutting, you had this new rock squeeze in to the old rock, and so it's younger. All right, inclusions, you have the old rock mixed in with the new rock. So the old rock, the inclusions are older. All right, and then we go to the next page. So this is like a puzzle. And so it's fun, right? Puzzles are fun. So we're going to put these in order, all right? And we're going to use our laws of superposition, which is just talking about the oldest ones are on the bottom, the youngest ones on top. Okay, inclusions are older than the rock they're in. And then cross-cutting are younger than the rock they're in. Okay? So the oldest has to be there first. All right? So what was laid down there first? So we have, this is not parallel here, so this would be, so actually C is the oldest. C was there first. Okay? And then A came in, right? A came in, and that was your intrusion, right? It goes this your intrusion here. A came in here, and parts of C are inside of A, right? So C, these are parts of C. You can tell by the it's like limestone. It looks like a brick. Okay, so C was there. So these are older. These are our inclusions, right? That's an inclusion, and they're older than the rock they're in. They're older than A. And then the youngest rock, see how this is our cross-cutting? So B, so all of those had to be there first, and then B is the youngest. All right, that's your cross-cutting. All right. And then we know C is the oldest because of this inclusions. All right, there's inclusions of C in the new stuff. And where you have this right here, these mean this rock right here is metamorphic. And that's because it's so hot here. There's heat and pressure here. And so this rock right here is actually metamorphic. All right, because there's a lot of heat and pressure. whereas this would be our igneous. So you have your igneous intrusion here, but right here along the edges, it's metamorphic. All right, and then this was our sedimentary, our nice parallel, laid down parallel limestone. Okay, so that is number 1. Now, for number 2, okay, so we're going to look at what's happening here. Remember, the oldest is always on the bottom, right? That is our superposition law, right? So what has to be, so E and B are on the bottom, right? B squeezed in here, so E had to be there first. In order for this to squeeze in, right? This intrusion, and in order for it to intrude and squeeze in the middle there, E had to be there first. So then comes B, right? B comes in the middle, all right? And then you have this weathering here, okay? You have the weathering, so that was the top layer, right? And then what happened is C, right? Now here's our law of superposition, where this is our limestone again, just gets laid down. These are our sedimentary rocks, right? Our sedimentary rocks just get deposited flat. So C, D, A. All right, so this is our superposition here. All right, they're just getting layered. All right, and then B is that's a cross-cutting, right? So it is, I know it's B cross-cut, it goes across of E, so I know B's the oldest. All right. Oops. Okay, so this next one, I'm looking at oldest to youngest. So again, I've got this, I'm going to use my superposition, right? Superposition, law of superposition. I keep saying that over and over. So the oldest is on the bottom, so that would be C, then E, right? So this is getting deposited, these parallel layers, the strata, C, E, D, and all the way up to, and then B, right? Those 4 layers have to be there in order for this magma, right? This magma comes in and starts to crystallize and cool, right? As it goes closer to the surface, it cools and solidifies and becomes my igneous intrusion, right? And so that is going to be the youngest. What letter is it? Did I? What letter is it? A. Okay. So again, that's cross-cutting. Right? A went across all of these, so I know it's younger than all of those. And it can get trickier and trickier. That's the fun. So let's look at this one. So the oldest is on the bottom, right? And like any puzzle, you know, everyone has their different strategies, right? Some people like to do the edges, some people like to do the, you know, whatever. And so this you could go, you don't have to go in order, you could kind of, I know the youngest is going to be on the top, right? And then the oldest is on the bottom, so that is B. B is actually this rock here that's going like this. Each of the kinds of rocks has a different kind of a code. All right, so B is the oldest, right? Now remember that how do rocks get deposited? They get deposited in these parallel layers. So C also had to have gotten deposited onto B, and at one time they were parallel. All right. And then D also would have gotten deposited parallel. All right, by our superposition, it's going to go B, C, D. Those would have been there. All right, and then now we have the faulting here, right? It kind of shifted, right? You can see that this kind of got slid down. All right, this is a fault. Okay, where the earth actually moved. And so that's why these lines, if I'm looking at this line here, right, it goes here, but then it picks up, right, it's shifted. All right, so that is a fault. So they were parallel, got laid on one on top of the other, and then the earth shifted. All right, so that would be M. Then the fault happened, the earth shifted. Then you have your lava came in here. All right, there is your cross cutting. All right, A came in. All right, there's your intrusion. A came in and went across. So it has to be younger than the rocks it goes across. All right. And then you can see, and that's why these in here, here's your metamorphic rocks, right? Where you've got heat and pressure, and the earth is getting squeezed. They're getting squeezed. So now you have law of superposition, right? These would have been laid down horizontally, E, F, and G. Got laid down horizontally. And then there had to have been a shift, a tilt. All right, the next thing that would have happened here, after G is laid down there, then you would have had a tilt. So something, you had your earthquake, and E, F, and G got tilted. And then the limestone on the top got laid down like that. Again, horizontally, okay? And if some kind of earthquake or something happens, you could have, it might get tilted again. You could have a fault, right? If you had an earthquake, it would, everything, would shift down. Okay, but so far, that is how that would go. And then number 5, we're looking at the oldest. So remember the oldest, law of superposition. Oldest is on the bottom, so G has to be the oldest. Okay. And I up here has to be the youngest. Okay, because it's on the top. All right, D is part of this layer here. Starts here, and then there was this fault, right? And it got shifted down. So I is on top of D. Okay. And then the next oldest would be H, right? It's going to go H, D, I, and that's our law of superposition. All right. And then I have G is the oldest. Well, what got laid on top of G would be C, right? Because C is here, right, and here. So it was laid down horizontally at one time, so you have C. All right, and then A is here and here. So it, again, had to be laid down horizontally. At one time, it was just all one layer. Okay. And then what happened is it shifted. You have this fault. It shifted up, right? You have this fault, all right, which is B, right? B is the fault. Okay, so it shifted up, and then that was the top layer of, this got weathered. This was the top layer, all right? So then this got weathered and eroded, and F got deposited. So there's like a whole story. We're telling a story here. So F got deposited, and then we had this shift, right? Another earthquake here, a fault here. All right, that's E happened, and it went down, and then I started to get deposited on top of that layer there. Every picture tells a story. And this is what makes geology fun, I think. If I was a geologist, I think this would be what I would like to do. And there's some cool maps we have in class of where you can look at places like the Grand Canyon and see all these layers. It's pretty amazing. So now we'll do the last one. All right, so you have the oldest, right? They're being laid down horizontally. Actually, we'll go ahead and do that in class. I'll go ahead and stop. This is already 20 minutes. No one's going to watch for 20 minutes. So go ahead and try that, and we'll check it together in class.